On the morning of the 6th of June, 1944, at approximately the same hour, on the same stretch of occupied French coast, two things happened that were so different in their consequences that they have shaped the debate about that morning for more than 80 years. On three beaches, Gold, Juno, and Sword, British and Canadian infantry wading ashore in the surf looked to their left and right and found 33-ton steel tanks surfacing from the water alongside them, guns elevated, canvas flotation screens dropping as the tracks found purchase on the beach. The tanks had swum to shore. They had been launched from landing craft at sea and had arrived under their own power at the same moment as the men they were there to support. Those beaches were taken. Gold Beach was secured with 400 British casualties from 25,000 troops, Sword with 630, Juno in 42 minutes. On one beach, Omaha, American infantry wading ashore looked for the tanks they had been promised and found whitecaps, oily bubbles rising to the surface where 32 tanks used to be. The tanks were at the bottom of the English Channel, and their crews were with them. The difference between those two mornings was not the courage of the men. The courage was present on every beach. The difference was the tools, and the tools had a name. Tell me in the comments, had you heard the name Hobart's Funnies before today? Because what you are about to discover will change the way you understand the most important morning of the Second World War. Now let's go. To understand why those tools existed, you have to go back 22 months before D-Day to a morning that began the same way and ended in catastrophe. On the 19th of August, 1942, a combined Allied force of 6,086 men, primarily Canadian troops, launched Operation Jubilee, a full-scale raid on the German-occupied port of Dieppe on France's northern coast. The operation was designed to test new tactics and equipment against a defended shore. By early afternoon, it was over. 3,623 men had been killed, wounded, or captured in 10 hours. The casualty rate was 67%. The tanks were the catastrophe within the catastrophe. The Allies had equipped the assault with the Churchill, Britain's newest and most capable infantry tank. It was faster than its predecessors and better armored. What it was not built for was shingle. Those rounded stones of the Dieppe beach surface destroyed the tank's traction within moments of landing. Tracks came off. 12 tanks were stranded on the beach immediately, immovable and exposed to every German gun that had an angle on them. 2 sank. Not one Churchill crossed the seawall. Not one reached the town. The infantry who had counted on armored support found themselves alone on a killing ground, and the killing ground did what killing grounds do. The Germans drew their own lesson from Dieppe. They began reinforcing their Atlantic wall defenses along the occupied coastline of Europe, a program of construction that would consume resources and labor on an industrial scale for the remaining years of the war. The lesson they drew ran in one direction. The lesson the Allies drew ran in another. Among the men who drew that lesson was a Royal Canadian Engineers officer named Lieutenant John James Denevan. Before the war, he had been a civilian engineer. At Dieppe, he had lost friends, not to German bullets specifically, but to the combination of circumstances that had left tanks stranded on shingle and men exposed on a beach without the armored cover they had been promised. He did not write a memoir about it. He wrote a report to the War Ministry describing a vehicle that did not yet exist, a tank modified at its core to carry Royal Engineers' demolition expertise directly to the places where that expertise was most needed, protected by armor, capable of performing engineering tasks on a defended beach that ordinary tanks could not manage and that infantry could not attempt under fire without cover. He requested development authority. he got it. What he built would eventually go ashore on the 6th of June, 1944, and do precisely what the Churchill tanks at Dieppe had been unable to do. But that was 22 months away. And before the machines could be built, the man who would build them had to be found. The difficulty was that the British Army had already thrown him away. Sir Percy Cleghorn Stanley Hobart was born on the 14th of June, 1885, in Nainital, in British India, where his father was a civil servant. He was educated at Clifton College, graduated from the Royal Military Academy at Woolwich in 1904, commissioned into the Corps of Royal Engineers, and served in France and Mesopotamia in the First World War. After the war, in 1923, he transferred to the Royal Tank Corps. This was the decision that would define his career, and, eventually, the outcome of the Normandy landings. Hobart understood the tank in the 1920s and 30s with the same clarity that certain men understand weapons before those weapons have been fully tested in combat. He saw what the tank could do, not merely as a support vehicle for infantry, not as a cavalry replacement, but as the centerpiece of a new kind of warfare. Fast, deep penetrating, coordinated with aircraft and radio communication, striking at a pace and depth that the attritional battles of the previous war had made literally inconceivable. By 1934, he commanded the 1st Permanent Tank Brigade in the British Army. By 1938, he was commanding the Mobile Division in Egypt, the formation that would subsequently become famous as the Desert Rats. He was also, by almost universal account, impossible to work with. Not because he was incompetent, because he was right, and he knew it, and he had no patience for people who were wrong. The British military establishment of the 1930s contained a significant population of people who were wrong about armored warfare, and Hobart treated them accordingly. He accumulated enemies with the same efficiency he accumulated correct predictions. He was argumentative, impatient, and constitutionally unable to pretend that a bad idea was a good one. In 1939, his commander in the Middle East removed him from his post, not for incompetence, not for any battlefield failure, for abrasiveness, for being the kind of officer who made his superiors uncomfortable by being right in ways they preferred not to acknowledge. He was 53 years old. He was retired. He went home. What followed was one of the stranger episodes in the history of the British military. The German army, which had studied Hobart's ideas about mobile armored warfare with considerably more interest than the institution that employed him, executed those ideas across France in the spring of 1940, routing Allied forces with a speed and completeness that left the British Expeditionary Force retreating to Dunkirk. Blitzkrieg was not a German invention. It was a set of ideas about armored warfare that Hobart had been advocating in Britain for a decade, and that the German military had found more persuasive than he had. During those same weeks, Major-General Sir Percy Hobart was serving as a corporal in the Chipping Campden Home Guard, armed with a piece of drainpipe with a bayonet welded to its end. The military analyst Basil Liddell Hart, who was among Hobart's few consistent advocates, published a newspaper article under the headline, "We Have Wasted Brains." Winston Churchill read it. Churchill, who had a talent for identifying effective men whom institutions had discarded, directed the army to reinstate Hobart. When the army objected, Churchill wrote to the chief of the Imperial General Staff in October of 1940 that the country could not afford, in wartime, to confine appointments to officers who had excited no hostile comment in their careers, and that the qualities and defects attributed to Hobart might almost exactly be attributed to any of the great commanders of British history. He then invited the 55-year-old corporal to lunch and reinstated him as a general. Hobart's opponents tried again. He was denied command of the 11th Armored Division he had trained, deemed too old at 57. They then attempted to remove him on health grounds. Churchill blocked both efforts personally. In March of 1943, Field Marshal Alan Brooke, the chief of the Imperial General Staff, summoned Hobart to his London office and proposed that he take command of the 79th Armored Division to develop the specialized armor that the anticipated invasion of Northwest Europe was going to require. Hobart asked for time to consider. He was deeply suspicious. 2 decades of institutional betrayal had earned that suspicion. He tracked down Liddell Hart at a friend's house in Stoke Hammond and took him into the garden for a private conversation. Liddell Hart convinced him that this was a chance that would not come again. The ex-corporal took the job. His condition before accepting was clear and non-negotiable. The division would be an operational unit with a genuine combat role, not a laboratory, not an experimental establishment that sat behind the lines while other men fought. He wanted his machines in the fight. He got that assurance. The 79th was renamed the 79th Experimental Armored Division Royal Engineers, and its insignia was a black bull's head with flared nostrils on a yellow triangle, carried on every vehicle the division produced. One detail about this arrangement that both men involved kept carefully unremarked. Hobart's brother-in-law was General Sir Bernard Montgomery, the officer who would command the Allied ground forces at Normandy. Montgomery informed Eisenhower of the need for specialized armor. Neither man drew attention to their connection, because each understood he would have to succeed, or fail, without appearing to benefit from family association. The relationship was the quiet mechanism. The machines were what mattered. The obstacle Hobart had been given 12 months to defeat was unlike anything previously constructed in the history of defensive warfare. The organization taught, which used slave labor and commanded resources on an industrial scale, had been reinforcing Europe's Atlantic coastline since 1942, at a rate that eventually consumed 200,000 cubic meters of reinforced concrete per month at its peak. When Field Marshal Erwin Rommel took over responsibility for those defenses in the winter of 1943-44 and toured them personally, he accelerated the program with the intention of making the beaches themselves the killing ground. Steel obstacles in the tidal zone, many tipped with mines. Concrete gun emplacements on the high ground. Minefields laid between the waterline and the fortifications. Anti-tank ditches behind the minefields. Gun positions commanding every approach with interlocking fields of fire. The Atlantic Wall was not one problem. It was 5 distinct problems stacked on top of each other, each requiring a distinct answer. The 79th Armored Division's operating structure was as unusual as the machines it was developing. It never fought as a division. Hobart commanded nearly 2,000 vehicles at the division's height, but those vehicles were distributed, lent on a mission-by-mission basis to whatever formation needed them. A squadron of flail tanks attached to a Canadian armored brigade, a troop of engineering vehicles supporting a British infantry division, a section of flamethrower tanks operating alongside American forces at a fortified port. This is why Hobart's contribution is difficult to find in standard accounts of the campaign. His machines appear in the records of formations he was supporting, credited to other commanders' operations. The 79th left almost no unified history because it never unified on a single battlefield. The training took place in East Anglia, Suffolk, and South Wales. The Allies built physical reproductions of the Atlantic Wall obstacles, based on reconnaissance photographs of the actual German defenses, and the machine crews rehearsed against full-scale replicas of the concrete emplacements, steel obstacles, and anti-tank ditches they would face on the day. The men who would drive into those defenses on the 6th of June had driven into copies of them dozens of times before. Hobart had approximately 12 months and 5 problems. He began with the one that would take a 33-ton machine into the sea. The first thing anyone watching from the shore noticed about the duplex drive, Sherman, was the canvas screen. It rose well above the tank's hull, higher from a distance than the vehicle itself, a collapsible flotation structure supported by rubber tubes that, when inflated, gave the tank enough buoyancy to remain on the surface of open water. From the beach, it looked like an oversized rubber boat with a gun barrel protruding from the front. This was the machine designed to solve the problem of armored support at the moment of landing. A 33-ton steel fighting vehicle kept afloat by canvas and air. The duplex part of the design meant exactly what it said. 2 propellers at the rear of the vehicle, powered by the tank's own engine, drove it through the water. When the tracks found the bottom and the vehicle came ashore, the same engine transferred power back to the tracks, and the flotation screen was dropped. The tank became, in the time it took to deflate and collapse the screen, a fully operational fighting vehicle. This was the tactical purpose of the entire design: to deliver armored support to the waterline at the same moment the infantry arrived there. Not minutes later, when landing craft could drive close enough to discharge conventional tanks, but in the first seconds, when the men crossing the beach most needed something between themselves and the German guns. The design required, in exchange for that tactical advantage, conditions it could not exceed. The screen was canvas. Canvas tore. The operating limit was Force 3 sea conditions, a moderate swell, manageable winds, organized waves rather than chaotic surf. There were 6 documented cases of carbon monoxide poisoning in trials when tanks were launched from more than 4,000 yards out. The engineers who built it knew exactly what it could and could not do. The question was whether the English Channel on the 6th of June, 1944, would cooperate with the specification. On 3 of the 5 beaches, it did. At Sword Beach, the 13th 18th Royal Hussars deployed 31 of 34 duplex drive Shermans. They swam ashore. The 3rd British Infantry Division advanced up to 6 miles inland that day. At Juno Beach, 21 of 29 DD tanks reached shore, and the 3rd Canadian Infantry Division took the beach in 42 minutes. At Omaha Beach, the sea did not cooperate with the specification. The United States Army's 741st Tank Battalion prepared to launch 32 duplex drive Shermans in the early hours of June 6th. The swell that morning ran to 4 feet. 4-foot swells exceeded the design limit. The canvas screens tore under the pressure of water they had not been built to resist. 16 tanks belonging to C Company sank immediately upon launch. 13 of the 16 tanks in B Company followed them down. 27 of 32 tanks went to the bottom of the English Channel. Their crews were inside them. The infantry reached the shore and looked for the armor that was supposed to be there beside them. They saw whitecaps, oily bubbles rising from the surface where 27 tanks had been. The men inside those tanks do not have individual names in the publicly available record of this engagement. They were young men, trained to operate an improbable machine in conditions that the machine had not been designed to survive, committed to a plan that the sea invalidated before they could execute it. The infantry who survived the beach at Omaha did so without them, through a combination of small unit courage and the brutal contingency of that kind of fighting. The cost of that morning would be counted elsewhere. The duplex drive Sherman was the first problem solved and the first machine lost when conditions exceeded its limits. The second machine had different limits. It had been designed by a man who had watched friends die at the problem it was built to solve, and it carried their weight in every pound of the 40-pound projectile it threw at reinforced concrete. Lieutenant John James Denovan's report to the War Ministry had described a vehicle unlike anything in the existing British order of battle. A tank modified at its core to carry Royal Engineers demolition expertise directly to the places where that expertise was needed, protected by the same armor that protected everyone else inside the vehicle. Where a standard tank carried a gun designed to kill other vehicles and suppress infantry. Denovan's machine would carry a weapon designed to destroy concrete. Reinforced concrete, the bunkers and emplacements and seawalls that the Atlantic Wall was made of. The weapon eventually fitted to the Churchill Armored Vehicle Royal Engineers, the AVRE, was a 29mm spigot mortar known formally as the petard and informally as something considerably more descriptive. The projectile it fired was drum-shaped, approximately 40 pounds in weight, and contained 28 pounds of high explosive in a warhead designed to transfer that force into masonry and reinforced concrete at close range. The crews who worked with it called it the flying dustbin. The name was accurate. It looked exactly like one. The weapon's effective range was between 80 and 140 meters. This meant the AVRE had to drive to within approximately 80 meters of the bunker it was attacking before the flying dustbin could be used, against a bunker built to kill vehicles approaching from the front. The tactical logic was straightforward in principle and violent in execution. Get close enough, fire the petard, demolish the concrete, move to the next obstacle. There was, however, a detail about reloading that no armored vehicle designer would have chosen if any alternative had been available. The petard mortar could not be reloaded from inside the vehicle. The barrel had to be traversed until it pointed over the co-driver's hatch. The co-driver then opened the hatch, reached upward, and pushed the new round into the barrel from below, with only his hands exposed above the hull. Not the rest of him, just his hands. In combat, at close range to a concrete emplacement, with whatever fire the garrison could direct at the vehicle working to destroy them, a man reached through a hatch and reloaded the weapon by feel. The Tank Museum's description of this procedure is delivered with considerable institutional restraint. Not the healthiest occupation in combat. Beyond the petard, the AVRE was designed as a platform for engineering attachments that addressed the layered problems of the Atlantic Wall. The bobbin carpet layer, 100 feet of canvas matting reinforced with steel rods and chestnut saplings, unrolled from a horizontal drum at the vehicle's front across blue clay beach surfaces that would swallow any vehicle attempting to cross without it. The fascine, an 8-foot diameter bundle of 11-foot saplings dropped into anti-tank ditches to fill them to a surface firm enough for following vehicles to cross. The small box girder bridge, a 34-foot assault bridge capable of spanning a 30-foot gap and bearing a 40-ton load, deployed in seconds. One vehicle, multiple configurations, depending on what was in the way. By the 6th of June, 1944, 180 Churchill tanks had been converted to AVRE configuration. One of them was designated 1 Charlie. It landed on a Normandy beach on D-Day. It got off the beach, crossing ground that would have bogged a conventional vehicle, and then became stuck in a ditch behind the shoreline. The decision was made to bury the tank where it sat to keep traffic moving. 4 of its crew were killed. 2 were injured. The tank remained in the ground for 32 years. When excavated in the 1970s, it was still leaking oil, still loaded with the ammunition its crew had brought ashore on the 6th of June, still containing their personal effects. It stands on display today, near the spot where it came to rest. Not in a museum in London, on the beach. The Imperial War Museum's assessment of the AVRE is direct. It was the most successful of the Funnies, and AVRE variants remain in service with the British Army today. From Denovan's report in the months after Dieppe to the Gulf War of 1991 is a distance of approximately 50 years. The same essential idea, a protected vehicle that carries engineers to the point of the obstacle and helps them destroy it, has not been superseded in principle, only refined in its execution. The AVRE solved the problem of concrete. The machine that solved the mine problem was built on a different chassis and operated by a different kind of courage. a German private of the 726th Infantry Regiment, 716th Static Infantry Division, was positioned near La Rivière on Gold Beach on the morning of the 6th of June, when a Sherman tank emerged from behind a ruined bunker with something attached to its front he had never seen before. A rotating drum held by two steel arms extending from the hull, from which hung a large number of heavy chains. The drum was spinning. The chains were crashing onto the earth with a noise that could be felt through the ground as much as heard above it. Clouds of dust and soil rose in the chain's wake. Several times, as the tank advanced, something exploded under the chains, mines detonating at a safe distance from the vehicle rather than beneath it. His officer ordered the men to hold fire until the 75mm anti-tank gun could be brought forward to deal with it. The gun did not arrive in time. Once, during the advance, a chain struck a mine, and the explosion snapped the link. The chain, approximately 3 meters long, flew upward and came down on two of the private's comrades. This, Private Martin Eineg would later record, was the moment at which whatever tactical confidence his unit possessed became considerably more difficult to sustain. What the private had witnessed was a Sherman Crab, a standard American medium tank fitted with a large rotating drum on two arms extending from the hull front, from which hung heavy chains with weighted tips. The drum was driven directly from the Sherman's own engine through a drive shaft, a crucial design improvement over the earlier Scorpion flail tank used at El Alamein in 1942, which had required two separate auxiliary motors to power its drum. The Scorpion's auxiliary motors were complex, unreliable, and difficult to manage on narrow landing craft ramps. Hobart's engineers eliminated them and ran the drum from the engine that was already there. The result was a simpler, more reliable machine that was faster to field and easier to maintain in combat conditions. The Crab retained the Sherman's 75mm main gun. When flailing, the turret was traversed to point rearward to protect the barrel from mine blast. But outside of mine-clearing operations, the tank fought as a conventional vehicle. Mine-clearing and direct combat, two distinct capabilities in one hull, applied according to what the terrain required at any given moment. The operating conditions were demanding. Crabs moved at approximately 2 kilometers per hour when flailing, walking pace in a straight line, with the boom extended, clearing a 9-foot-wide path through the minefield ahead of them. At that speed, in that configuration, a team of 3 Crabs advanced into the field together, while 2 reserve tanks held behind the cleared ground. The dust cloud produced by the chains was considerable, which provided some concealment. On uneven ground, the boom sometimes rose, causing the chains to miss the surface and leaving gaps in the cleared lane that appeared safe, but were not. These were known limitations, documented in trials, accepted as the cost of a system that remained dramatically more effective than the available alternative, which was human beings on foot with metal detectors. The crews of the Crab squadrons built an identity around the dangerous work they had defined themselves around. By the final months of the war in 1945, Command proposed converting surviving Crabs back to standard Shermans, the flail equipment removed, the tanks returned to conventional use. The Crab crews strongly resisted. They had built a professional self-definition around driving into minefields at walking pace and trusting the chains to find the danger before the tracks did. The proposal to make them ordinary again was received as something close to an insult. The institution eventually moved on. The point is not who prevailed in that argument. The point is that the machines had produced, in the men who operated them, a professional identity tied to a form of work that had no equivalent anywhere else in the Allied armored order of battle. The Crab cleared the path. At the end of that path waited a concrete bunker housing men who had been trained to fight from inside it until they were killed or until the position became indefensible. Hobart's answer to that problem breathed fire. There is a moment in combat at which a defender, who has weighed his options, concludes that the rational course of action is to keep fighting. He has cover. He has ammunition. The walls of his position are concrete. What is approaching him is a tank, and tanks can be killed. He has done the calculation and found the situation survivable. The Churchill Crocodile was designed to change that calculation. The Crocodile was a Churchill Mark VII infantry tank with the hull-mounted machine gun replaced by a flamethrower projector. Behind the tank, connected by an armored pipe that ran under the vehicle's floor, it towed an armored trailer containing 400 gallons of petroleum jelly, a gel form of incendiary fuel that burned hotter than standard petrol, adhered to every surface it contacted, and continued burning after the initial ignition. The projector could force this material from the trailer through the pipe to the front of the tank and ignite it at a rate of 4 gallons per second, projecting a stream of burning fuel to an effective range of approximately 120 yards. The turret's 75mm gun remained fully operational throughout, which meant the Crocodile was simultaneously a conventional tank and a flamethrower vehicle, and the crew could choose between those functions according to what the moment required. The armored trailer could be jettisoned from inside the tank if it was hit. This detail matters more than it might initially appear. The Crocodile crew was not more physically vulnerable than the crew of a standard Churchill. The fuel was stored outside the hull, in a trailer that could be disconnected under fire. If the trailer took a direct hit, the tank's armor remained intact. The psychological weight of being the formation the enemy feared most was a different matter entirely. The approach was systematic. The 75mm gun fired first, to suppress the position, to damage the structure, to force the occupants to keep their heads down while the Crocodile moved closer. When it had closed to within 120 yards, the projector was brought into play, burning petroleum jelly at 4 gallons per second through any gap in the structure, a firing slit, a ventilation opening, a crack in the concrete produced by the preceding gunfire. Inside reinforced concrete, at close range, there was no position the burning fuel could not reach if there was any opening for it to enter. The Crocodile had another mode of operation that was, in a precise tactical sense, more effective than the flame itself. Before igniting the projector, the crew could spray unignited fuel, coating the exterior of the position, saturating the ground around it, allowing the sight and smell of petroleum gel covering the bunker to communicate exactly what was coming if the occupants chose to remain. This was called the wet squirt, and it was the most psychologically effective variation of the weapon. Not the flame itself, but the moment before the flame, when the men inside the concrete understood what was about to happen and had to decide whether to stay or come out. Many came out. On the 7th of June, 1944, the day after D-Day, Churchill Crocodiles operating near Gold Beach were used in their intended role for the first time. They approached German defensive positions. Approximately 150 German troops surrendered under a white flag. Not after the flame projector had been used, after seeing the Crocodiles approaching. A German veteran, in post-war testimony that entered the documentary record of the campaign, describes the Crocodile as something his unit came to know as the Flammenpanzer, the flame tank, and states that it produced a hugely demoralizing effect on every formation that encountered it. A weapon that altered the calculation a defender makes about whether his position is survivable before the weapon had been fired. The Crocodile's response to a position that chose not to surrender was demonstrated with particular completeness on the 14th of September, 1944, at Fort Montbarey, near the French port of Brest. The fort was an 18th-century French fortification occupied by German Fallschirmjäger, elite paratroopers, among the finest infantry in the German order of battle. The defenses they had prepared included a 40-foot masonry wall, a 40-foot earth embankment, a historic moat 40 feet wide and 15 feet deep, a 10-foot anti-tank ditch, and a 200-foot wide minefield laced with buried 300-pound naval shells fitted with hair-trigger detonators. A major American bombing effort had produced craters without meaningfully reducing the defenders' capacity to hold the position. 3 crocodiles under British Lieutenant Hubert A. Ward were assigned to the assault. Before they reached the minefield, the second crocodile struck a buried naval shell. The detonation destroyed the vehicle instantly, killing the driver, and the wreckage blocked the path forward for the remaining tanks. Ward directed his lead crocodile forward alone, through the minefield, without support. 1 tank in a 200-foot belt of buried naval shells, advancing on a position held by paratroopers who had prepared their defenses with considerable professional thoroughness. The Fallschirmjäger began running from the pillboxes outside the fort's walls. More than 75 surrendered to the American infantry, advancing behind the crocodile. They had held that ground against bombing. They held it against artillery. When the crocodile came through the minefield alone, they came out. Ward was subsequently decorated for what he did in that minefield at Montbarey. The fort fell. The crocodile was the most psychologically devastating of the 5 machines. The 5th machine was psychologically devastating in an entirely different way. Not to the enemy, but to the institution that had built it. The Canal Defense Light is a name designed to tell you nothing about what it was. That was the point. A Greek civilian named A.V.M. Mitsakis conceived the idea in 1937 and sold it to the British War Office. Mount a powerful searchlight in a tank turret and use it during nighttime attacks to disorient enemy soldiers at the range at which they were most lethal. The War Office carried out development trials under conditions of great secrecy. By late 1939, a turret was ready for production. In American service, the vehicle was designated the T-10 shop tractor. Neither name bore any relationship to what the machine was designed to do, which was to blind people at 300 yards in the dark. The turret replaced the tank's standard gun with a housing for a powerful carbon arc searchlight positioned behind a narrow vertical slit with a rapidly opening and closing mechanical shutter. The flickering produced by that shutter, an extremely bright light switching on and off at high speed, was the weapon. It was exceptionally difficult for a human eye to determine the distance to a flickering light source of that intensity and darkness, which meant that a soldier trying to aim at the vehicle producing it was working with degraded information about range and position. Allied tanks using the CDL vehicles as illumination would close to effective range in the partial darkness beyond the beam's edge, visible to the CDL crews, but not clearly visible to the defenders, being dazzled at its center. 300 turrets were produced from Matilda tanks. When the Matilda became operationally obsolete, the turrets were transferred to American M3 Grant medium tanks in British service, producing the Grant CDL. The Americans were sufficiently impressed with the concept to order 355 of their own searchlight turrets, fitted to M3 Lee tanks, and designated, again with the particular creativity of military camouflage, shop tractors. By the time the Normandy invasion was being planned, the Allied order of battle contained approximately 635 CDL vehicles across British and American forces, with trained crews, maintained equipment, and rehearsed tactics for deployment. None of them were used at Normandy. The British 35th Tank Brigade and the American 9th Armoured Group were in England in June of 1944, equipped, trained, and ready. The planning process for the Normandy invasion had not incorporated them. The reason was not a tactical judgment about the CDL's effectiveness. It was simpler and more damaging than that. The CDL was classified at a level of secrecy intended to preserve its element of surprise, which required its existence to be withheld from officers who did not have a demonstrated need to know. The problem was that the officers who needed to know in order to include the CDL in their planning were frequently not among those who had been cleared to know it existed. You cannot plan to deploy a weapon you have not been told about. Rather than sit idle, most CDL units were converted to other roles. Trained specialists were reassigned to ordinary work because the institution could not find a way to deploy them without compromising the secrecy on which the weapon's entire tactical logic depended. The CDL saw use. It saw it late and not for its intended purpose. During the Rhine and Elbe river crossings in the early months of 1945, one British CDL squadron and 64 American CDL vehicles returned to service with their former crews, deployed to illuminate the river surface at night for crossing operations. Not to blind defenders, to light the water. The searchlight, designed as a dazzling weapon, became a useful electric lamp. Its one genuinely operational moment came at the Remagen Bridge over the Rhine, where German frogmen attempted to destroy the Ludendorff Bridge at night, using swimmers with floating mines dropped upstream. CDL tanks illuminated the river, exposing the swimmers. The frogmen failed. The bridge held. The canal defense light, designed to disorient infantrymen at 300 yards in the dark, spent its most effective hour of the war exposing swimmers trying to blow up a bridge, a task that bore no resemblance to the purpose for which it had been built. A weapon produced in 635 copies, trained for by specialist crews, classified into operational irrelevance by the system built to protect it. 5 machines. The question was what 4 of them would do together on the morning they had been built for. On the 6th of June, 1944, 160,000 Allied troops crossed the English Channel in the largest seaborne invasion in history. 5,000 vessels carried them. 11,000 aircraft flew in support. 5 code-named beaches stretched for approximately 50 miles of the Normandy coast. The German Atlantic Wall awaiting them had been under continuous construction for 2 years. The concrete was real. The minefields were real. The guns were real. The 79th Armored Division went in the first wave. At Sword Beach, 31 duplex-drive Shermans swam ashore and provided immediate armored support to the 3rd British Infantry Division as it crossed the beach. The 4th 7th Royal Dragoon Guards and Sherwood Rangers Yeomanry at Gold landed their armor directly from landing craft when weather made DD swimming inadvisable for that sector, while Crab flailed tanks and Churchill Avers cleared 13 of 18 planned lanes through the minefields and beach obstacles. At Juno, 21 of 29 DD tanks reached shore, and the 3rd Canadian Infantry Division was moving inland within 42 minutes of the first troops arriving. The 79th Armored Division's own final report states that the overwhelming mass of armor in the leading waves, the specialized equipment arriving as a complete surprise, overwhelmed and dismayed the defending troops and contributed in large part to the comparatively light casualties suffered on the 3 beaches where the Funnies were deployed in full. That is an institution assessing its own performance. It is not a boast. It is a report. The United States Army's formal assessment of Gold Beach, produced separately by a different institution with no interest in crediting British equipment, states that a major factor in the success of the Gold Beach landings was that the British assault forces were lavishly equipped with armor and Funnies of the 79th Armored Division. When the Army, whose general had declined the Funnies for its own beaches, formally credits the Funnies for the success of the British beaches, the argument does not require additional advocates. Those numbers, taken together, are the argument's simplest form. Gold Beach. 400 casualties from 25,000 troops landed. Sword Beach. 630 casualties from 29,000 troops. Juno Beach. 1,200 casualties from 21,400 troops, taken in 42 minutes. Omaha Beach. Approximately 2,500 casualties, where 27 of 32 D.D. Shermans had gone to the bottom of the channel, and the infantry crossed without the tools the other beaches had. These numbers do not establish a simple causal relationship. Omaha's terrain was different. Its bluffs, its restricted exits, the weight of its German defensive preparation. The historians who have examined this question in the decades since D-Day do not agree on a clean verdict, and the evidence does not support manufacturing one. Those numbers do establish, without dispute, that the beaches with the full complement of specialized armor produced casualty rates measured in the hundreds, and the beach without it produced casualties approaching thousands. Major-General Sir Percy Hobart was not on any of those beaches on the 6th of June. He was at his headquarters, receiving reports as they came from the formations that had been lent his machines. The DDD tanks at Sword, the 13 lanes cleared at Gold, the beach taken in 42 minutes at Juno. He had spent 12 months building machines that nobody outside his division had called anything but funny. On the 6th of June, 1944, he found out whether they worked. They worked. The argument about the American beaches and the Funnies began before the gun stopped firing on that morning, and has not concluded since. General Omar Bradley, commanding the American forces at Normandy, had been offered the full range of Hobart's specialized armor and had declined most of it. His stated reasoning was logistical. Accepting Churchill-based variants would require retraining American tank operators and maintenance personnel and creating a completely separate supply chain for spare parts for a tank design entirely different from anything else in the American order of battle. Bradley acknowledged in the same statement that had the Funnies been developed early enough for their features to be incorporated into Sherman-based designs, the Americans would probably have used them. There is also this. Bradley's memoir does not mention the decision. An officer who had made a logistical calculation that he considered defensible would normally be expected to defend that calculation in his own account of the campaign. The subject does not arise. The omission is not proof of anything specific. It is evidence of something. The post-D-Day record, by contrast, admits no serious dispute. In July of 1944, 9 Sherman Crabs were transferred to the 1st United States Army for use during the Normandy breakout. American forces requested and received Churchill Crocodile support for the assault on Brest in September. British machines operating alongside American infantry at Fort Montbarey, because the tactical need for the flamethrower against fortified positions was considered sufficient justification for whatever supply complications their presence created. The resistance to the Funnies that had characterized the D-Day planning dissolved repeatedly when American commanders encountered the tactical problems the Funnies had been designed to solve. After Normandy, the machines continued working across Northwest Europe. At Le Havre, Boulogne, and Calais, in September of 1944, Crocodiles and aviaries reduced heavily fortified German garrison positions in the port cities that controlled the supply lines the Allied campaign required. At the Battle of the Scheldt, specialist armor supported the clearing of the river estuary that would open the port of Antwerp. At the Rhine and Elbe crossings in early 1945, D.D. Shermans crossed 2 of the great rivers of Europe under conditions considerably less extreme than the English Channel on June 6th. By the 20th of August, 1945, when the 79th Armored Division was formally dissolved, it had been associated with approximately 7,000 vehicles across Allied forces in Europe. A formation that never deployed as a unified fighting unit, that was lent in pieces to anyone who needed it, that appeared in the records of 20 other formations rather than its own, had embedded its machinery across an entire continent's worth of fighting. The institution that had named them Funnies had found them, in the end, indispensable. The debate about what they might have done at Omaha, had they been there in full, remains genuinely unresolved. Both positions, that the Funnies would have made a measurable difference and that Omaha's geography would have complicated their deployment even had they been available, can be supported by evidence. The appropriate conclusion is not that one side is obviously right, but that the question is real, that the stakes were real, and that the record from the 3 beaches where the Funnies were used in full establishes what those machines were capable of producing under conditions they had been designed for. Hobart never said much about this publicly. He had built the machines had gone ashore, and he considered the record sufficient. The machines did not stop being useful when the war ended. Centaur bulldozers, variants of the engineering vehicles the 79th Armored Division had developed, saw service in Korea between 1950 and 1953. Churchill-Avry variants fought in the Gulf War of 1991, 47 years after the vehicles that preceded them had gone ashore on Normandy beaches. The Imperial War Museum's assessment is unambiguous. Avro vehicles remain in service with the British Army today. The concept that Denovan proposed in the months after Dieppe, a protected engineering vehicle carrying demolition capability directly to the point of the obstacle, has not been superseded in principle, only refined in its execution. Major-General Sir Percy Cleghorn Stanley Hobart was appointed Knight Commander of the Order of the British Empire and awarded the American Legion of Merit in 1945 in recognition of what his division had contributed to the Allied campaign in Europe. He retired from the British Army in 1946. He died on the 19th of February, 1957, in Farnham, Surrey, aged 71. He had lived long enough to see his machines go ashore on 5 beaches, cross 2 major rivers, and reduce fortress positions that conventional forces had been unable to touch. He had lived long enough to be vindicated. He died without substantial public recognition of what that vindication represented. The Royal Tank Regiment stated its assessment in a tribute produced 60 years after his death, that pride was taken in the innovation and adaptability Hobart and his predecessors had shown, and that the requirement for an inquiring mind and an innovative approach remained as relevant in the modern British Army as it had been in 1944. The bull's head insignia of the 79th Armored Division no longer appears on active British vehicles. What the division produced does. The Canal Defense Light leaves a different kind of legacy. 635 vehicles, trained crews, classified into operational irrelevance by the system built to protect the weapon's surprise. The lesson the CDL teaches is not confined to 1944. A secret that cannot be shared with the people who need to act on it is not a tactical advantage. It is an institutional liability, wearing tactical advantage's clothes. Hobart himself left one observation on record that captures the argument of everything he built. He asked, with the impatience of a man who had spent years explaining something that should not have needed explaining, why armies should piddle about making porridge with artillery and then send men to drown in it for 100 yards of no man's land. Tanks, he said, meant advances of miles at a time, not yards. He was speaking about armored warfare in general, not the Funnies specifically. But the Funnies were his fullest answer to his own question. 5 machines built on the conviction that engineering properly applied to a problem was worth more than courage applied to a problem that engineering could solve. They called them funny. That was the name the institution reached for when confronted with a tank that swam, a tank that threw dustbins at concrete walls, a tank that flailed chains into the earth until things exploded, a tank that breathed fire at 4 gallons per second, and a tank that pointed a searchlight where its gun should have been. The Funnies, said with the slight inclination of the head that communicated, without requiring anyone to say it outright, that the man building them was not quite the right sort. The man building them had been a corporal with a drainpipe. He became, at Churchill's insistence, the commander of a division whose machines are still in service in the British Army today, and whose most significant contribution to military history was reducing the casualty rate on 3 of the 5 beaches of the most consequential amphibious landing ever attempted to a fraction of what the beach without them produced. 400 casualties at Gold, 630 at Sword, 1,200 at Juno, the canvas skirt, the dustbin, the chains, the fire, the searchlight that was too secret to aim at anything useful. These were the strangest tools of the Second World War, and the distance between how ridiculous they looked and how precisely they worked is the distance in which the real history of D-Day is written, and the man who built them spent the last years of his life in Farnham, Surrey, largely unknown to the country whose soldiers they had kept alive. If you think he deserves to be remembered, leave a comment below. And if you want to understand the other war Britain almost lost before it started, watch this next.